Welcome everyone to this panel meeting, and thank you for signing up. Thanks to all the panel members for this panel discussion. We hope that it will be super insightful. So just to give you a little bit of context and background on what STFC Food Network is. For some of you who are not here from the UK, as I can see, UKRI is like one of the funding bodies in the UK, and within UKRI there are 9 different sort of divisions. STFC is one of them, which is standing for Science and Technology Facilities Council. This particular organization, this particular strand of UKRI normally funds physicists. So any type of physicists, particle physics, nuclear physics, computational sciences, space science, and all those different areas of physics. Within UK, we have 3 big campuses of Science and Technology Facility Councils, where thousands of scientists are working in physics-related area, nuclear physics, particle and astronomy. It is based just out in outskirts of Oxford in Harwell campus, and another one is based in between Manchester and Liverpool. It is Daresbury, where Hartree Centre resides. You might have heard quite a lot in terms of big data analytics, AI, machine learning, those sort of technologies that has seen a lot of applications in space sciences and physics related area. However, this network has now tried to bring in different sort of people, not primarily working on food, to work in food with people specialist or specialization who have specialization in food systems, whether from production or supply chain angle or consumer behavior angle, to come together, co-design projects, co-develop some ideas, test some of those ideas to the projects funded by the network. So we have very conveniently distributed food systems into 3 different strands: production, sustainable food production, supply chains, and nutrition and consumer behavior. And what we try to do in STFC Food Network is to look into the capabilities that STFC has. So the physics-related scientist would have is from data science, technologies, and facilities that we have in the UK, which cuts across, and most of these facilities are also looking into the material science aspect, which cuts across one or more of the strands of food systems to address one or more of the challenges faced within the food system. So we are very happy and to report that we are now more than 1,500 members from over 25 countries, not just from academics, but also industries and policymakers. So we do work quite a lot on challenge-led research. So the challenges coming from either policymakers or the industries or the farmers community. So any of those challenges, we try and run a few events with them for co-designing the projects. So we do quite a bit of work with the help of fantastic team members that we have. And this slide is slightly older. We have more members now in the project management team. Paulina is here helping us very kindly. So thanks, Paulina, for being a backbone of running all these experts working group. There's a lot of people in COIS and steering committee whom we rely on for the advices, and we do take a lot of help from them to run this network. Our key people running these networks are the champions and the liaisons. Some of them are also involved in these expert working groups, and I'll come to those in a bit. So just in a summary, what we have done so far. So this network is running since 2017 in the first phase. In the first phase, which was running for 3 years, we were only focusing on the UK-related food challenges. In the second phase, we started running from 2020. We are 50% focusing on UK-related food security challenges, but also looking into challenges across different countries in Africa and Asia, particularly developing and lesser developed and least developed countries. And we have funded around over just 100 projects, scoping projects, which are smaller projects, and a little bigger is a proof of concept projects. Now, since this year, we have launched expert working group. And the idea behind expert working group is to bring those learnings from those different projects. So let's say if we have funded a project on cold chain in India, a similar sort of project is funded in Kenya, in Uganda. What are the common learnings? What are the common themes emerging? What are the challenges that runs across in the similar agroclimatic zones? And what are the differences, the key differences? And how the tech and the data science is enabling us to resolve or address some of those challenges. Now, this bioeconomy and smart food system is a very unique expert working group, mainly because we didn't have any particular project specifically focusing on bioeconomy. However, there were certain elements in one or more different projects which could potentially address some of the things and some of the key issues within bioeconomy. So here we are looking forward to the panel discussions to bring and to give us some insights on how the bioeconomy and sustainable smart food system has a connection, and what role does food system has to play within bioeconomy. The idea again for these expert working groups and the main audiences for these expert working groups are threefold basically. One would be like, if there are any sort of policy initiatives coming across from these expert working groups, then we would be having some policy briefing. If there are any industry implications or the standard operating protocols or the standards that needs to be looked into, then the industry would be our audience. But especially for this particular expert working group, we are hoping that UKRI and other funding agencies would be our main audience, because there's a lot to do within this sphere. So it would be a very good starting point to have panel discussions, have an understanding from their perspective and their experience, and share, if they are sharing their experiences, then we will have a follow-on sort of discussions on what more needs to be done, what more needs to be researched, and how we can bring in the community together back to address some of these challenges. And I will just end with one of my new roles that I'm playing with NERC, which is another UKRI focusing on environmental impact. So all the different things related to the environmental sciences and the impact. And they have started looking into bioeconomy and how that could be providing some of the solutions towards reducing environmental impact, and how do we move forward towards a net zero economy. Okay. So I will pass it back to Cyril to steer the discussion with the panel member. But I really hope that you enjoy this panel discussion. And I'm so much looking forward to this. I thank all the panel members to provide your time here for this discussion. And we hope that this is just a beginning of the conversation. And we are looking forward to it.
Thank you, Sonal. Thank you so much. Yeah, I mean, hopefully we think it's going to be more interesting than eating a packet of plain rice cakes. We're pretty sure it's going to be more interesting than that. So as far as I'm concerned, I'm really grateful for the opportunity. I've been working in the food industry for 20 years now, over 20 years, across the value chain of innovating small and medium businesses. And in the last 3 years, thanks to COVID, let's say, I've been supporting food businesses in their journey towards a better understanding of their impact on food systems, because at this stage, we're still there. They start to understand before action, actually. So I'm going to introduce very soon our speakers. Just a word on our bioeconomy working group. So it has been masterly chaired by Dr. Luisa Watuko from the University of York. And we've been basically buzzing with reflections and proposals. So besides this panel discussion, there's been a couple of outputs. So PI interviews and also a position paper, and both aim at assessing, let's say, the potential for current and future sustainable food systems research, and also the areas of importance for future funding. So that's where we are. Right. So now I'm going to introduce my co-host, because I'm come from the food industry, so I'm not an expert in food systems. So I thought, oh, I need someone who knows a bit more. So I've got Steve. We've got Steve Houston, and I'm going to let him introduce himself, and then I'm going to be like a 5-year-old. I'm going to ask a lot of questions, and he's going to have basically 5 minutes to answer. So it's quite, and it's not black or white questions type of answer. It's more like, it's a bit more complicated. So let's see how he does with it. To you, Steve.
Thank you, sir. I hope you can hear me. I've been having a little bit of trouble with the microphone. Is that okay? Or can you hear me?
Not well.
Very, very low.
I think it's your mic is probably, or your headphones are not.
Okay. Is that better?
There you go. That's perfect.
Okay.
Fantastic.
Right. Okay. Yep. So thank you, Sarah. So yeah, I'm a food scientist. I've been working in basically the dairy industry in New Zealand for several years, and then I moved back to Europe, and I've become more and more interested in food proteins. So my interest in bioeconomy stems for two reasons. I was asked a few years ago to become the editor-in-chief of a bioeconomy journal, and at the time I really didn't understand an awful lot about the bioeconomy. I was working in one particular aspect, but that gave me a really broad overview of what the bioeconomy means and just how complicated it is. So I'm interested in this particular workshop, and also the SFM Plus network as a whole, to try and get out of it, how can the scientific facilities that the STFC provide, how can they help us understand particularly food systems and how to make foods more sustainable and economically more viable. So yeah, that's my background. I'm based up in Edinburgh, which is an awful day today. It's rainy and horrible, as it usually is in Scotland. And yeah, I think that's all I really can say about myself.
So are you ready? I'm going to bombard you with the questions now.
Yes,
ready?
I'll try and answer these. Yep.
There we go. So you got literally 5 minutes. So so Steve, what's the definition of bioeconomy, or more, are there definitions of the bioeconomy? Is it some sort of interchangeable buzzword with sustainability, circularity, regenerative? And what does it mean for the bioeconomy to be sustainable? Also,
Okay.
So I'm going to ask you all the questions like a 5-year-old, angry because I don't know. And can the bioeconomy help solve the unsustainability of the current food systems? And also, what is a smart food system? Is there something such as not smart food systems? And how does it contribute to its sustainability?
Okay, I should add before I start that this is my view. I mean, you may disagree, everybody may disagree, but that's the whole idea of this. It's to sort of promote a discussion. And if you do disagree, say. So in terms of definition of bioeconomy, there are lots of different definitions of the bioeconomy because it is so very broad. When we were looking at this, the report output for the working group, we found one definition by the Global Bioeconomy Summit that I think is a fairly good summary of what the bioeconomy is. And they say it's the production, utilization, conservation, and regeneration of biological resources, including related knowledge, science, technology, and innovation, provide sustainable solutions. They include as information, products, process, and services within and across all economic sectors, and enable a transformation to a sustainable bioeconomy. So I mean, that's a huge definition. It covers absolutely everything, from the science through industrial production, but also things like the law that surrounds bioeconomy as well, social issues, socioeconomic issues as well. I think at its simplest level, what the bioeconomy is, it's basically about using biological resources sustainably and responsibly to create a new economic model that protects the planet. And if we think about it like that, then we can't go too far wrong. You asked about, does bioeconomy equal sustainability? Well, I would say not necessarily. There are concerted to make the bioeconomy sustainable, but it would be incredibly easy, and we probably already do it, to use biological resources in the same way that we're using other resources, so petrochemical resources. We could just call it the bioeconomy, but it's still unsustainable. And I think in a sense, that's already happening, with what people would call greenwashing. There's a lot of people saying, oh, we're using, we're part of the bioeconomy. But when you look closer at what they're actually doing, it's not an awful lot different to what the current practices are. For it to become sustainable, we are going to have to commit to changing the way the economy works. That is not necessarily something that we can do on our own. It requires government input as well. And sometimes governments don't want to do that. That they're not particularly good, well, not all governments particularly good at placing the environment at the center of their economic models rather than money, economic health as the primary goal. So it's going to take trade-offs, and they need to be explained to the general public, to everybody really, and discussed. And if people are prepared to take these trade-offs, then yeah, a bioeconomy is possible. A sustainable bioeconomy is possible. I think the other one you said was, can the bioeconomy solve the unsustainability of the current food systems?
Yes or no?
Well, solve is a big word in this context, and I think it can contribute. You think about the food system, I mean, it already is a bioeconomy, so we're not creating something new. We just have a bioeconomy in the food system that doesn't work as well as we would wish it to. So the type of initiative we're trying to put forward here, I would see as being about improving sustainability, what we already have, rather than reinventing it. And that's probably about as much as I would want to say on that. What is the smart food system, and how does it contribute to sustainability? I mean, this is quite a difficult one. There are, the way I see it, there's a number of different aspects to the food system that we should be interested in. One of them is nutrition. Can we design foods that are more healthy for us? I don't think people sometimes don't think of that as being part of the food system, but in today's world, that's really important. Food and what we eat is a big part of the problem that we have with health in this country, particularly obesity. So can we go some way towards actually changing what we eat? It doesn't necessarily mean processing of foods. It may mean different crops, and the way in which we, or the types of food we eat. I think also we need to look at improved productivity, and that means using new technology to improve yields, robotic sensors, smart agriculture, that sort of thing. And I think that's what people think of more as a smart food system, is using those types of technologies to actually get more out of the land we have, but at the same time also improving the quality of the food. Another aspect is food security. We're very reliant on crop food imports in the UK, particularly, and other food imports. So reducing that reliance, and that's going to go a long way towards sustainability, making it more sustainable as well. If we don't transport food, then we have reduced greenhouse gas emissions, and we have reduced food loss in general, and that's going to improve the sustainability of the food system. Another big aspect is reduced wastage. So reducing both processing waste, household and food service waste, but also finding ways to add value to the co-products and byproducts we form. In other words, a circular economy in the food system. And the final one, which is probably going to be the hardest one, is basically mitigation of things like climate change. So finding ways to protect against the effects of global warming on crop and animal food systems. How do we do that? How can science contribute to that? That's which is a massive issue, and one I wouldn't really want to get too involved with. So I think that basically summarizes.
You've done well.
You've done
well. Thank you, everyone. Goodbye. He said it all. No, that's not that. No, that's not what we want. No, thank you, Steve.
So
no,
there's really basically just to promote discussion. So.
Yeah, absolutely. Yeah. To promote the discussion, as you rightly said, I'm going to introduce our four speakers. I'm going to introduce them in order of appearance. It's like a casting, like a cast. And I'm gonna ask them basically if they've got anything to add first to your to what you just said. Okay. So first, I'm going to start with Duncan. Duncan Williamson has he's got over 25 years of experience working in the food, farming, and environmental sectors. He set up and managed programs on agroecology, sustainable diets, and food system for WWF UK and International Compassion in World Farming, the CIWF, and Action Against Hunger. He co-founded and he chairs Eating Better, which now has 63 member organizations, and he's got his own consultancy, Nourishing Food Systems, which is specialized in research, policy, and advocacy strategy development and delivery in the food, agroecology, land management, and I think it's quite important, just transition sector. To you, Duncan. So what do you think, just briefly, what do you think of Steve's input? Have you got anything to add, just very briefly, and then we'll go back to you after?
No, I mean, I thought that was brilliant. And the only thing I would just say is that I think you can't really look at the bioeconomy without looking at food systems because they are so integral to each other. And if you get food systems right, built on a good bioeconomy, you're going to solve many of the other problems the world faces. But if you get one or the other wrong, we're never going to be able to tackle the climate, water, or the biodiversity crisis that we're facing.
Okay, yeah, no, thanks for that. So now I'm going to introduce Dr. Parag Acharya. Does that pronounce it well, Parag? Yeah, is that correct? Apologies if it's if I didn't pronounce it correctly. So Dr. Parag Acharya is leading alternative protein-based food research and innovation at the Natural Resources Institute, the NRI, at the University of Greenwich. See, I haven't said Greenwich, and I'm French, so that's not bad. Brownie points for that. And Parag has returned to academia in 2020, bringing 14 years of industrial R&D experience in food and biotechnology sectors, including 10 years at Unilever, where he delivered patented clean label product and process technologies for brands like Knorr and Hellmann's, and championed several academia industry collaborations. At NRI, Parag has developed Medway Food Innovation Center, which includes a plant-based food accelerator, and is now working as Innovation Growth Manager for Growing Kent and Medway Agri-Food Cluster. Basically, he's a busy man.
Thank you.
So what's your view as well? Have you got anything to add?
I think Steve and Duncan already mentioned, I kept a lot of aspects of that. Fantastic. I would say one way to look at that, of course, the food system is a very complex part, in a way, because it consists of various actors or stakeholders and practices, which is directed by, policies and regulations. So I think one of the part which I'm very keen to see is the impact that bioeconomy actually brings. And of course, as the previous speakers talked about, the various challenges we are facing in that aspects, basically, when we talk about valorization, we talk about upcycling. I think one part is the process, that what process we will, in the food production system, we will take. And we know currently the food production and process that we are taking is very energy intensive. So I think one of the things is the shifting from fossil fuel directed linear system to more of circular bio-based system is to use more of bioprocessing. And that, as Steve mentioned very rightfully, that requires a lot of development in the science and technology areas where we are particularly keen to contribute.
Thank you, Parag. Now on to Dele. Dele Raheem holds a doctoral degree in food sciences from the Department of Food and Environmental Sciences at the University of Helsinki, Finland. He is also an associate professor food microbiology at the University of Helsinki, and you obtained pedagogic training from the University of Greenwich, London. There you go. Dele's research interest is in food bioprocessing, preservation, and other cross-cutting issues related to food security and safety in the Arctic. So currently he's affiliated to the Arctic Center at the University of Lapland as a senior researcher. And Dele will be today our expert on the intersection of food systems with other systems and how they can be integrated rather than compete with each other. So Dele, your turn.
Yeah, thank you very much, Cyril, for the warm introduction. So I'm joining you from Lapland in the northern part of Finland. So I think if you want me to respond, I think the previous speaker, Steve, and the expert also, you know, they kind of, they have taken most of the word out of my mouth already. So, but I think if I can add, you know, because usually when we talk about food system, you know, it's very complex, and we have to bear in mind that it has been reported that on average, you probably need about 7 to 10 calories of energy to produce just 1 calorie of food, because a mix of food, energy, and water, if you look at the whole system from production up to consumption, so a lot of energy at play. So we need to manage this in a very sustainable way. And of course, with bioeconomy, this is something that is quite on the rise now, that we need to think of our individual health as well as planetary health. So all the stakeholders that are involved within the food system, we need to bear in mind that we've got only one planet, and with issues of climate change, so whatever we do contributes to the greenhouse gas emissions. So we need to operate within this planetary system. So I will stop for now until I have a chance to present further. Thank you.
Well, I suppose you'll talk about circularity a lot, no? Am I right to think that?
Yes.
Yeah.
Yes.
Okay. So now on to Lucy. So there you go. Let me find your bio, Lucy. So thank you very much as well for your participation. Lucy is Business Development Director and Lead Consultant for Anaerobic Digestion at NNFCC, a strategic bioeconomy business consultancy based in not Greenwich, York. Lucy has worked with the business and in the bioeconomy for 20 years, advising private and public sector clients on development and delivery of and compliance with energy and waste regulations. Lucy is a leading advisor on anaerobic digestion, AD, in the UK and Europe, and will use the AD market as an example to illustrate the importance of waste, the role the public and private sectors play in this industry, and the benefits to be realized along the way. So that's going to be a great insight. Thank you. So Lucy, your views on the...
Yeah, thank you, Cyril. Thanks for the introduction. Yeah, I think the previous speakers and Steve kind of have introduced the bioeconomy and smart sustainable food systems very well. I don't think there's a lot more to say, but I think just to kind of reiterate, we are feeding a very hungry economy at the moment, and I think that will continue to grow. So we do need to kind of accelerate this move away from fossil fuels, as the previous speakers have said, and kind of sustainability and the bioeconomy are kind of integral to achieving that. So reducing consumption, identifying and using alternative materials are fairly critical to this. So biomass feedstocks are kind of a big part of the move towards more sustainable future, and integral to the bioeconomy. And I think with this, there's still a lot of debate and discussion around kind of the priorities for that biomass. And I think it's really clear, we need kind of clear policies to really guide those priorities to ensure that the biomass feedstocks are being used in the most sustainable way to deliver a kind of solution. And I think also it's kind of been alluded to in the previous by the previous speakers, I think food security and energy security very much comes in hand, and both are a big part of the bioeconomy. So just need to be kind of conscious of the bigger picture when we're talking about sustainable food systems as well.
Right, so let's see. Thank you, Lucy. So big topic, let's spark some controversies. So we basically ask every speaker to do their homework on one question. So let's see how it goes. There are 4 fundamental questions. So I'm going to start. I'm going to go back to Duncan, and I'm going to ask him the 1 billion pound or dollar or euros question, which is Duncan, is the bioeconomy an opportunity for the transformation of the agri-food system?
Yes, it is. Yes, it is. Do you want me to give you my presentation? Because I prepared some slides.
Yes,
on
please. Yeah,
yeah.
feel free.
I will do that. I will do that for you. But yeah, in a nutshell, you're completely right. It is a huge opportunity for the food system, and they should work together. Okay, let's get this. How can I bring this all up? So yeah. So when it is, can you see my slides yet? I was working earlier.
Taking a time, but
It will come. It will come. I'm sure. Otherwise, I know what I'm going to say. But yeah, so yeah, the bioeconomy and the food system, they need to work together, and I very much think that they are an opportunity to work together going forward into the future. But what I think we have to do is almost go back to basics when we look at a lot of this, because when you think, should I just stop sharing? It's not working. Again, and I'll just try one more time. My presentation has died. Weird. Sorry. Sorry. Typical. Right. So, okay, so forget it. I'm just going to.
Never mind.
Never mind. I'll just do this on my own anyway.
Or instead
so, yeah.
of full screen, Duncan, can you just play?
Yeah. Okay. I'll try that. I'll try that for me. But yeah. So I had to do. I would just play it as it is like this. Let's try it one more time. It should work. Reloading it. There you go. So yeah. So,
Yeah, just play this. Yeah.
Fantastic.
Good. So yeah, but first thing I want to do is I really want to focus on sort of definitions around this, because what I've found in my sort of 20 odd years of working on food systems and in the environment and conservation is people are always changing definitions, and when a new concept comes up, people will often use it to either mean business as usual, or they'll hijack the definition of what it means. The example I'll give you like this says the term plant-based. I remember when it was first started being used, I was one of the people in the room that decided, as amongst the NGOs, that we needed to talk around sustainable diets in a more positive way. And the concept for that was plant-based. And that was based on the nutritional idea that every plate of food you have should be based on plants. And once you put the plant, because the first thing you put on the plate is the thing you put the most of on the plate. So if you put plants on the plate first, so your veggies and all that, and your beans and that, then you put your carbohydrates, and then you put your protein on it, and it doesn't matter whether the protein's meat or whatever, you will actually eat a far more sustainable diet because you're eating less of the bad food, because people were overeating protein. It was never, ever meant to mean vegan. But what happened was very quickly, the term got co-opted to mean vegan. And so now you're seeing a term that doesn't mean what it was meant to mean and has 100 different terms. And you see that across with things like regenerative agriculture, agroecology, and you're going to see it with bioeconomy. So what I thought was, I really want to be clear about what I think food systems are. And food systems are different. They're messy, they're complicated, they really are. But for me, a food system must provide equity, food nutrition security, accessible sustainable diets, and accessible is the key part for this, restore and regenerate land and water, mitigate and or adapt for climate change, and the 3 justices. And the 3 justices are what inform nearly all the work I do and nearly all the thinking I do. And it's a frame that I love. It's interspecies, intergenerational and intragenerational, which essentially is the just transition. And I think that if a food system can deliver those, you have a sustainable food system. If it is failing on any of those 3, you have an unsustainable food system. So that is kind of shaping a lot of the narrative that I'm using here. So I do like this definition of a bioeconomy. You can read it for yourself. And for me, as you think, the goals of a bioeconomy are the reduction of GHG emissions, efficient use of energy and material, responsible consumption, social inclusion and innovation, and just transition. So, and I would argue that those are also the exact same goals of a sustainable food system as well. So they interlink really, really closely. But what really got me was I sort of looking at the WBCSD, and this figure for the economic opportunity for bioeconomy absolutely blew me away, because I think it's really important to come up with, to recognize the financial case for this, because for too long in the last 25 years, I've heard people say, once again, it's going to cost too much. Oh, we can't afford to do it. Oh, no, no, no. We've got to have business as usual to otherwise we will sort of marginalize the poorest of society. But what we know is the current system is rewarding shareholders, creating billionaires, and is making a more driving inequity in society and in nature. So you have to have a business case to change that mindset. And I think the business case is really, really clear. And that is before you bring in the whole broken subsidy system, where trillions of dollars are used every year to support agriculture and fossil fuels. And if you change those subsidies alone, you could afford to shift the whole of the food system to a sustainable food system. You could tackle the climate crisis, the biodiversity crisis, and the water crisis. So the funding is there. So any debate around bioeconomy needs to have the financial bit front and center, because again, my experience of working with governments is they listen to the business case rather than listen to the moral or the ethical case. So what is happening with the food system at the moment? Well, fundamentally, the food system is completely and utterly broken. We have a food system that I would argue is increasingly failing. We're seeing harvests fail every single year. It's going to get worse. It's not just because of the war in Ukraine, climate change, the floods in Pakistan drove food prices up. We're seeing harvests failing every year. We're seeing fish stocks collapse. But the food, and this is all because we're stuck in several things. We have a cheap food paradigm where we're producing more food that is cheap as possible with very, very low nutritional value, often owned by various corporations. And this food paradigm is reliant on the unsustainable use of natural resources. It has massive health outcomes. We recognize that almost 50% of the global population is malnourished. And it's driving inequality. It's just a crazy food system that doesn't work, other than a few shareholders. I mean, we've seen that the retailers around the world, at the same time as food poverty is on the rise, retailers, as a result of COVID and post-COVID, are making record profits while food prices are going up. So there's something going a bit wrong there. We also have a food system where it is the predominant use of land on the planet. So if you're going to sort of move to a bioeconomy, food system has to be central to it, because of the available habitable land on the planet, 75% of it, 71% of it is being sort of, the vast majority of it is being used for food in some way, shape or form, whether it's pasture, crop growth, etc., or wild food as well. And then you dig down into it, my personal bugbear is, though that there are this, I love this figure, 250,000 species of plants on the planet, about 12 crops and 5 animal species provide nearly all our calories, which is absolutely insane. And particularly when you look at some of the crops of corn and maize, soybeans, sugar, crops that necessarily we shouldn't be eating in large quantities, and crops that are really good at being refined to create ultra-processed food and cause diet-related ill health. So we have a food system that is really, really broken. And we need to start looking at that. So what do I think about this? So I think the bioeconomy can deliver many of the goals of the sustainable food system. If you have a decent bioeconomy, it will improve food and nutrition security. It will provide healthy and sustainable diets. It will optimize the use of natural resources in food production. You integrate cycles across value chain, you increase efficiency, you do more recycling. There's so many things you can do with this that gets me really excited. It's a really positive step forward if it's done correctly, and that if it's done correctly is really important to me. And as I've alluded to, poverty reduction has to be central to every of this. And this is important. It goes down to who owns the bioeconomy, how it's benefiting the poorest in society, and how it's being used, what are the property rights around the bioeconomy. We don't want to go down the route that GM went down, where it's only owned by a few companies, or you see a couple of companies own most of the seeds on the planet. It also has to build resilience. And I think resilience is really, really important, and the bioeconomy can do this, because we are seeing the impacts of the climate, nature, and water emergencies. And if we don't build resilience into a food system based on nature, we're going to see more disruption happening, and that's going to affect everyone from people in Tanzania to London to New York. So there's so many things. I got a bit in the weeds when I was looking at what the bioeconomy can support related to foods. I sort of read loads of stuff and went down that rabbit hole. But the four things that came out of what a bioeconomy can do for a food system, which are going to be essential, is going to be new food sources. Yes, some of them will be technological ones like cellular meats, but personally, I get excited about seaweed, which isn't a new food source. We've been eating it for thousands and thousands of years, but yeah, we forgot that we were eating it. So biofertilizers and biopesticides, they get me excited because they're not fossil fuel based. They're more natural. You can do some amazing things with them, and they should be more affordable going forward as well. And they're not going to damage the natural environment so much if used correctly. And then my personal one is agroforestry. I love agroforestry. We need more trees. In England, we are the most deforested country in Europe and one of the most deforested countries in the world. We also have some of the lowest biodiversity in the world as well. And I just think we need to get back into trees, get back into agroforestry. They provide so many services, from flood alleviation to biodiversity restoration to even providing shade for animals, for livestock. They're brilliant. So a bioeconomy supports so many opportunities, and all of these opportunities will benefit farmers. They'll benefit producers because they can either save money or make money from them, and that's important. So let's have a look at just a few things. So I dug into livestock and bioeconomy because it seems that my life in the last 15 years has always come back to livestock in some way, shape or form. And I just think livestock and bioeconomy are such a wonderful symbiotic relationship that currently they can work together. Currently, livestock is the biggest use of land use change. It causes biodiversity loss, contributes to GHGs, and uses vast amounts of water. However, livestock also provide nutrition, income, fertilizer, fuel, soil, restoration, their community status. I mean, some people, you give them as dowries. 500 million people in the world, their only asset is livestock. And I think livestock are part of a sustainable food system going forward. And with the bioeconomy, you can start working with them to recycle nutrients, provide energy like biogas from methane. That's got to be looked at because it's happening. And they can build resilience. They have more economic opportunities for farmers. They can help farmers adapt to climate change going forward and provide better food and nutrition security and economic security for families. And then we can also use our byproducts. It's not just about using their manure on fields and stuff like that, but we can use our things like food waste. If we're going to have food waste, let's feed it to animals. Let's feed it to animals, so we don't need to grow so much soy. We don't need to grow so much maize for the animals. So I think livestock and bioeconomy is something I'd love to see a lot more research on, a lot more discussions around, because it's really fascinating. And now, just finally, I'm going to go on to the two solutions that I think will deliver a sustainable food system. The first is agricultural diversity, which is the whole variety of plants, animal, microorganisms and ecosystems that contribute to food and agriculture. And this is really exciting. The more food, the more types of food we can get into the system, the more sustainable it will be. And the more culturally appropriate they'll be, the more adaptable, the more resilient they'll be to changing climates. We need to move away from this monoculture-centered system. And I think the bioeconomy really fits into the whole concept of agrodiversity really well, because it's about using nature better. It's about the opportunities that come from it. And you can look at a bioeconomy at every level, genetic, species and ecosystem level. So I think agricultural diversity should be the forefront of every food plan. And it should be something that it will deliver a lot of the outcomes of the bioeconomy, particularly deliver the social outcomes that are going to be so important, because then you'll be growing the right food in the right environment for people, not food that's going to be reliant on loads and loads of inputs that is going to be more vulnerable to climate change. And then the other side of the same coin for me is going to be sustainable diets. And sustainable diets are really interesting. They're exciting. There's something that when I first started working on that I was once called a food fascist for talking around sustainable diets by the Daily Mail in the UK. And when we started working on it, it's a really odd idea. No one really got hold of it. It was only WWF and the Brunner Foundation and the UNEP who were really working on it. But now it's getting quite mainstream, and they're not about going without. They're about being more in tune with what your body wants and with what nature can provide. So it's eating less meat, of course it is. It's eating less protein, but it's eating more plants. It's eating more sort of complex whole grains and carbohydrates. And every single study in the last sort of 15 years has said exactly the same thing. A bioeconomy is basically built, a sustainable diet is built around half your food should be vegetables, beans, pulses, whole grains. Half your plate should be. Then carbohydrates, then your proteins, then your sweet treats, your cakes, your biscuits, your chocolate, that sort of thing. And a sustainable diet really will deliver a sustainable food system. It's part of it because it will drive the change. And it will always be built on several things, like a variety of foods, and eating more plants is absolutely key to a sustainable diet, as well as wasting less. And I include this here because a lot of the stuff I've read about bioeconomy basically seems to say that the core elements of a bioeconomy are also the building blocks of a sustainable diet. And so I think these are two mutually very, very supportive things that you have to think about together, and they will deliver sustainable food systems. So to conclude, I think the bioeconomy and food systems go hand in hand. I think bioeconomy has so many opportunities to tackle some of the biggest problems that we are facing if it is done right. I always worry about the fact that it might be hoovered up and mean 101 different things. It can't be left to go into the hands of just the corporate sector, who might misuse the term, might end up going down doing previous mistakes, like I mentioned about GM. It should be a term that we should defend, but it should be a term that is built around the three justices if we're really going to deliver it so it meets what it should be meeting and the potential for it. And I'm very excited about it. And I do thank you, Cyril, for giving me the opportunity to reacquaint myself with this term and then really research it a bit more in detail over the last few weeks. Thank you.
No, thank you, Duncan, and thank you for highlighting, for getting all the excitement about the bioeconomy, and there's a lot of potential. But at the same time, I think you mentioned a few, what could be blind spots, around justice, biodiversity, even, local communities. There's a lot of questions still, just to make sure there's a holistic approach to the concept. I think we're going to keep a lot of questions for the end because we're running a tiny bit late already. Maybe I think Steve has got a question for you, if that's okay. Unless one of the speakers has a pressing question. Yeah,
I mean, it was a very interesting talk, Duncan. A lot of things there to think about. One question I have, I mean, you gave a lot of solutions there to how we might develop a sustainable food system, but what do you think is the biggest barrier to that? What's really going to get in the way of achieving this?
Yeah, I mean, for me, I think the biggest barrier for sustainable food and for bioeconomy is I hate to say the current system. I think the current way the market system is set up, there's so many vested interests in the current industrial food system that it's going to be you have to overcome them. And that was one of the reasons why I highlighted the role of subsidies, because I think subsidies are going to, if we change the subsidy system, and there's a movement to have that, it changes the whole economic model behind the current food system, which makes a lot of it less, which makes it less economically viable. So that has to be part of it, which is why I think a solution has to be the business case for change.
Yeah, I mean, you mentioned sustainable diets. That's incredibly important. It's something I'm, very much behind. But we've known for a long time what we should be eating, but the British public seems to be incredibly resistant to changing their diets. I mean, does this feed back into what you said about vested interests? Is it just that the message isn't getting through, isn't being given, or do you think there's something a bit more fundamental than that?
Yeah, I know. I think it's a bit like the whole climate change debate from 20 years ago when I was working on it in the 90s actually, where there's a lot of misinformation happening and vested interests. Though the solutions have been known for many years on food, and were on climate change, there was a lot of vested interest in the status quo. And so you are seeing that as I mean, people have used the pandemic and things like food poverty as an excuse for delaying change. So in the UK, they're delaying the sort of restrictions on junk food advertising because it's saying it's affordable, and they're using food poverty as an excuse for that. So there is a lot of people who don't want the change to happen, even though we know the solutions. And behind that, there's a whole weight of groups in the ultra processed food industry who they make a lot of money out of this. It's a really profitable sector. And the solutions on sustainable diets are more around whole foods, less processed foods. They're around vegetables, plants. You can't make as much money out of that. So why do they want to change? And they will fight this tooth and nail. The tobacco lobby did it. The fossil fuel lobby has done it. The aeroplane lobby are doing it. And I'm afraid to say the big food companies are going to keep doing it.
I mean, if you start, Duncan, on the whole sustainable, healthy diet, it won't stop.
Yeah.
Let's save that for the anyway. We'll have time at the end anyway for all those discussions. And yeah, absolutely. Thank you, Duncan. Fantastic. So next is Parag. I'm going to talk as well about something which can be controversial, which is around technology and research and innovation. So the question to Parag was, how can research and innovation in the bioeconomy accelerate the transition to sustainable food systems? Good luck with that.
Thank you, Cyril. Well, I think, so should I share my screen?
Please, yeah.
Can you?
Please.
Yeah. Almost there. Yeah, if you start presenting, please. Good.
I think, well, come back to your question, Cyril, about that why we need the research and innovation. I think this already been spoken, but just to set the context that, I mean, there are certain big challenges that we are facing, and that's how we came in the start of the discussion, that why bioeconomy. As you see, like, I mean, one of the area is the food waste. So basically, huge amount of food waste, how we convert that food waste into a more resource efficient and sort of like create value from the food waste. So I think if we think of the research and innovation, that's one part where we see like, okay, converting this food waste into value creation. And also another part is the emission. So basically how we generate low emission technologies, which actually supplement or rather replace some of the current food manufacturing things. And I think Duncan has explained wonderfully about this whole resilience and biodiversity. And totally you can see, like, I mean, currently 15 crops providing 90% of the food calories. So how we can basically come out from that. Now that I think we all know, I mean, that is also supplemented with this climate change. So basically, we think about technology, we think about innovation, but at the same time, we are a little bit sort of limited with in terms of production, in terms of yields of the production. And if we sort of continue the status quo, if we continue the way we are producing things, and that also feed more mouth in years to come, and that has a consequence. So basically, we need to rethink the sourcing, manufacturing, consumption. And I think that is the whole point of like why we need innovations and technologies. Now, I just would like to go into that part where we say, okay, I mean, in terms of food waste, yes, we need to reduce, we can reuse, we can recycle, but I think also to address some part of the industry lobby, because of course the industry lobby is, it's doing a lot of damage. I totally agree with Duncan, but at the same time, if you really would like to make an impact in the society, you need to reach the innovation research into the consumers. I think one way is that how we transform the food manufacturing, the industries. And in that part, of course, industry is going for a profit. It's a profit-oriented direction. And in that part, we say, okay, we can reduce, we can reuse, so basically in terms of circularity, but at the same time, can we upcycle? I think that is one of the big part where the research and innovation in the bioeconomy can deliver. So basically creating the value. So if we think of the crop residues, if we think of the grassland, if we think of the forest, now in a linear economic model, we process that, and we get into the food that comes into consumers, and we know, I mean, it's not working. The question is that if we actually produce a lot of side stream, a lot of co-products, which are currently sort of unutilized, now in order to reutilize that, can we create more value from those resources using the bioprocessing, using the green technologies? And I think that's where you can actually combine the interest of companies, at the same time serve the purpose of the whole sustainability and things. And well, I think that's the question, that how we want to do that. Now, I think in that part, I mean, I'm not going into details of that. Many of you have already aware of this whole circular bioeconomy, but I think in that part, the critical element is the value optimization of the biomass. Because if currently what is waste or side stream or co-products, once it started creating value, the price of that biomass will increase. Yeah, and then of course, the question is how you will actually, go into this next level of technology, next level of innovation, and see, okay, how you, optimize the value of the biomass such that the end products that goes to the consumers become more affordable, and then the transition is more just, as Duncan mentioned. So I would say that, previously, people thought about more on transitioning in a way that use the residues and waste and go for bioenergy, biofuel. I think that some extent was not very successful. Of course, that related to a lot of other factors like, price of the fossil fuels and things like that, which was not very timely and things. But at the same time, if we can upcycle things, so produce more valued end products based on that, maybe that's also gives the farmers, the stakeholders and the players at the frontal part of this whole supply chain a more fraction of the profit. Yeah, I think, and that's also another way, gives a kind of affordability for the consumers. So I mean, on that aspects, I think let's say that, if we think of like food waste, yeah, I mean, of course, it needs to be accessible. You need to transform the product. But at the same time, we talked about a lot of times technology. I mean, technology is one thing, but also you need to have, like I said, the market pool and how you sustainably, manage that. And I totally got the point of Duncan that, that, okay, I mean, the market pool sometimes creates a distortion in a way that if it's not very sustainable, but at the same time, if you don't have the market pool, you will not reach to the consumers. So from that part, maybe what you need to understand that the gap, the consumer needs, the tension. And I mean, what I'm talking about, the consumer tension, is from all across the consumers. It's not only in the developed world, but also in the developing world. And so the consumers have different needs and different tensions and different price points. So if we understand that and try to relate that, how that actually the technology can give that push of the value creation or value unlock, and that will actually market will pull that. And that we call it in terms of the product claims. So if you say 100% natural, if you say clean label, or better taste, and we talked about like, why people don't go for certain products, which we know it's sustainable, we know it's better, healthy, nutritious. But I think one of the aspects is that because, I mean, think about ourselves, when we as a consumer go into the supermarket, there are so many varieties, so many options, which to choose. And one of the aspects is that if it's good for me or not, that kind of idea. And can the technology and innovation in the bioeconomy, within the bioeconomy periphery, can deliver that? I think that's one of the aspects. Like, for example, I mean, I can give one clean example about the flavorings. Many of these food products, we have a lot of flavorings, which is added chemicals. Now, can we replace that with natural, say, fermented flavorings, which is based on bioprocessing, but that's a natural way of generating flavors rather than adding chemicals. So that's how you can create the value, and that also goes to serve the purpose of the consumers, and then you sort of have the technology push can create that market, align with the market pull. And in that, one of the examples, many of you are aware of that, is, say, for example, in the dairy part, in the cheese making process, you get whey protein, which is a kind of side stream for long. Now, typically, this was used for animal feed, which has a value of around 4 to 5 pounds per kilogram. Whereas by using novel technologies, now it's not novel, but we are talking about years back, that we created a protein isolates, which is good for many of the bodybuilders and others, which created a more high value product from the same sources just because of the technology and innovation. And I think that's also creates, and there was a need from the maybe a niche of the consumers. I'm not talking about this is like en masse, but niche of the consumers. And that's where we got it. So I think these are a few of the examples I would say that how the technology and innovation could actually adhere or align to the market pull on that aspects. And total diet as such, I totally agree. It's not, when we talk about alternative protein, I think it's a misnomer that people try to think that it will replace the meat or dairy. It's not. It's actually complement the emission intensive meat and dairy sector. So if we talk about if we think about $1 trillion or $1.5 trillion business of meat and dairy, if you think of that, even 10% of that, if replaced, or 20% of that is replaced by this alternative protein, there was some calculation says that will reduce, for UK perspective, around 55 or 60% of the emission comes from the food. Now, if that is true, we are not talking about really replacing, now going for vegan or vegetarian. We are talking about a kind of balance, and the balance. And I think that also requires a kind of technology and innovation. And from that aspects of the balance, I think in terms of ultra processed food, I would like to a little bit focus on that because this is very much related to alternative protein, which is one of the core area where I work. And in terms of that, just going into into that part. So there are different types of alternative proteins, and of course they have their pros and cons, and there are a lot of opportunities on that aspects. However, I think many of the process that we call ultra process, I definitely agree. For example, some of the extrusion, which was used initially in this whole, meat alternative production, is quite ultra processed. The question is, and then here the relevance of bioeconomy comes, that can we bring bioprocess, more green technologies, more bioprocess into replacing those kind of highly thermal and mechanical process of extrusion. And I think that's one part where there is a huge opportunity for alternative protein areas. And also another opportunity is, if you think of the manufacturing business, the equipment manufacturers, I think for long, because our food environment is such, our food manufacturing environment is such, that people are very much focused on core manufacturing equipments talked about extrusion, we talked about drying, all these things, which are very emission intensive, energy intensive. Now, the question is, can we, in terms of preservation, in terms of transformation of the ingredients, can we use more bioprocessing? And I think that is one of the core, question and fundamentals that, and also more, knowledge and scientific understanding needs to be developed. And then coming back to the manufacturing sides, because there are a lot of companies who can actually get benefited by developing, bioprocessing, for example, the fermentations. I mean, fermentation is one of the area where there are a lot of, lack of understanding, the lack of knowledge, as well as there are also the efficiency. Because, when we talk about fermented proteins or cell-based proteins, cell culture, I mean, all requires a lot of yield because of the fact that I think, many of the cell-based concept came from pharmaceutical, life science sector. Now, in life science, the amount of protein we need for making vaccines, making, medicines and others, I mean, it's minuscule compared to when we talk about a volume-based supply chain of food. And I think that's where the biggest unlock requires, that how can we actually deliver hundreds of thousand tons of proteins, through bioprocessing. I mean, currently we're not able to do that, but maybe in future. And that's where I think the skills, that's where the innovation, that's where the technology and science insights are needed. And again, coming back to that of a white space where I think the alternative protein sector should very well play a role in that.
Perfect. Thank you, Parag. Yes, it's very interesting. Thank you for insight on the on the market, how to engage businesses, alternative proteins, and you talk about upcycling, which not something but sprang to my mind, as someone is from the outside. So I'm really conscious of time constraints, but as any speaker or Steve, have you got any question that you would like to ask now, or we can keep it for the end?
No, I mean, just a comment really. I mean, what I really liked is sort of the juxtaposition between Parag's talk and Duncan's. One was looking at how the food industry can help develop the food system sustainability, and the other one is looking at I won't accuse you, Duncan, of being anti-food industry, but it was more on the side of we need to change. So I just like that. I think we have to, personally, I think we have to be somewhere in the middle, but that's something that can be discussed later.
Not sitting on the fence, but being in the middle. Right, okay. So yeah, we're gonna move on to Dele now, and Dele is gonna. The question for Dele is about food and non-food systems. Food and non-food systems. Sorry. So how can they be connected or integrated to develop a coherent and sustainable bioeconomy?
Yes, thank you. I try to share my screen. I hope you can see what I'm sharing.
So just to let you know, we are a little bit behind. Yeah. So I'm not asking you to be shorter, obviously, Dele, just to be aware of time constraints. Yeah. Thank you.
Yeah. Thank you. I go to presentation mode. Yes. Okay. So, well, the previous speakers have tried to already set the background to my topic. So, integrating food and non-food systems to develop a coherent bioeconomy. So, in terms of circularity, we often talk about this 3R: recycle, reuse, and recover. And also, Parag just mentioned this upcycle, which is also very important when we think about the circular economy. So basically, this is something that has been alluded to, this definition about bioeconomy. So I won't go into that. So I put here #CBEco. This is from a project that we were involved in recently and is still ongoing. this is about circular bioeconomy from theory to concepts. So it's a project between 2 universities in Finland and 2 universities in Argentina. So it's ongoing until end of December. So we're looking at how from different fields, there are from chemical engineering, food science, anthropology, looking at circularity within extreme polars, the Arctic and the Antarctic in Argentina. This is something that we are trying to combine that knowledge to see what we can draw in terms of maybe some parallels or some comparison or what needs to be addressed more or less. So, and again, this is something from the European Committee of the Regions, looking at what is happening within trying to move from a fossil-based economy to a more circular economy. So this is using better what we already use. So in terms of the natural resources, we need to ensure that efficiency. Also, we need to ensure that there's food security, especially when we think about looking at the individual health and the planetary health. And of course, where this issue of trying to upcycle more is using well what we don't use yet. So in terms of the side streams or other things that might have while producing from the natural resources in terms of food and agriculture. So essentially, to my mind, it seems that efficiency is a key word when we try to integrate food and non-food system to develop that coherent bioeconomy. So by integrating, what we have and using the technology that are available at this current moment. So already we're talking about what they call the industrial or agriculture 4.0, whereby we make use of all those latest technology, in terms of robotics, AI, these are digital solutions that will improve the efficiency and manage the resources within the planet in a more better way. And of course, we have to bear in mind that climate change and the food system, they are quite interrelated. The way we produce food, they contribute to the greenhouse gas emissions. And at the same time, when the climate is not good, if there's cases of drought, then agriculture will also suffer. So there will be less supply of food in this society. So, and again, so this is, we need to recognize that the food system is not just only about the food itself. As has been mentioned in various reports, that on average, you need about 7 to 10 calories of energy to produce 1 calorie of food. And this is where the nexus of the food, energy, water, they come in. And of course, we also have to consider in a more holistic way to recognize those multiple systems, like within the food, energy, materials, also the aquatic. These are quite important aspects to look at it from a very holistic point of view. And if you want to unlock the potential of aquaculture from the seas and the oceans, because our planet is 70% water. So we need to ensure that across the system, we are able to ensure efficiency, whereby we are able to generate those data across different systems. They need to speak to each other and also identify those ecological boundaries. What are the trade-offs? What are the clusters and the intersecting value chains to ensure sustainability? So again, with circular bioeconomy, it's truly a bio-based circular carbon economy, one that removes, also efficiently utilize and sequester more carbon than it emits. So from a sustainability perspective, it is important to ensure a sustainable bioeconomy, not only a bioeconomy to meet the sustainability challenges. So these are quite something that was highlighted from this European Committee of Regions. And again, the food systems, occupy the biggest niche of the bioeconomy. This is within the EU, the food systems, from production to consumption, accounts for 71% of all the value added in a bioeconomy, and it is followed by around 28% bioproducts, and the remainder are from bioenergy. So again, this is a publication, a recent publication looking at sustainable and circular bioeconomy in the climate agenda. So we have to bear in mind, the impacts of climate change, and especially in the Arctic space. On average, it's 4 times higher than the other parts of the world. So, and again, I'm going to looking at this. It's from 2021 on sustainability. Looking at the different parts of this figure, A, B, and C. So where A is about the components of a proposed working circular economy definition, looking at how to close those loops within the circular economy. You have to integrate the energy, which is renewable, also reuse materials from the post-use goods by recycling. This is about resource flows, and of course, extending the utilization of these goods for a longer period of time. And for B, we're looking at so I'm trying to change my slides now. Let me. Okay, B is the representation of a sustainable bioeconomy, renewable biological resources to renewable products, from biopower, biofuels, and bioproducts, from photosynthesis, drawing CO2 from what is happening within this production of energy, and also with feedstocks from forest, biorefinery, and the other bioproducts. Finland, where I'm based, is the most forested country in Europe. Over 70% of the land space is a forest. So this issue of circular economy within the forest and the non-wood forest system is very pronounced here, whereby we have in some cities, there are this so-called kind of a circular city whereby you have industrial symbiosis. So we have some companies, they are set up near each other whereby they can feed into the waste product from industry A, can be utilized in industry B, and so on and so forth. And for C is representing the circular bioeconomy resulting from the intersection of a circular economy and bioeconomic concepts. And the key word is to have that sustainable production and consumption, by utilizing the bioeconomy, replacing fossil-based resources with biological resources, and also generating less amount of waste. And for example, within the food system, with food waste is regarded as the third, if it was a country, after China and the US, food waste would be the third country that emits most of this greenhouse gas emissions.
Sorry, Dele, I don't know how much you got left.
Okay, I'm winding up.
Yeah, okay, thank you so much.
Okay, so, and again, just to talk about the UK, this is from the Department for Energy Security and Net Zero, that, the strategy policy is very important, and the proposal for decarbonizing all sectors of the UK economy needs to meet that net zero target by 2050. And from Finland, the Finnish government they have a bioeconomy strategy, and the strategy is aimed to double the value added of bioeconomy in an ecologically, socially, and economically sustainable manner that will make the country climate neutral by 2035. So thank you, and greetings from the Arctic. Thank you.
Thank you, Dele. I know they're all very broad and just compelling topics. So thank you for your presentation. I think you've touched on the question of the resources and the availability, and I think the question of governance might be part of the things that we can talk about during the Q&A because competing strategies on the national level can be difficult to manage, I suppose. So now we're gonna go to unless someone has got a question. Sorry, no. We're good. Okay. So Lucy now. Sorry, Lucy, to keep you waiting. So now, so the question for you is about public and private sector, and how they can enable the convergence of smart, sustainable food systems and the bioeconomy. And you're going to take the anaerobic digestion as an example. So thank you so much for your patience, and we all ears now.
Thank you. Thanks, Cyril. And thanks to the previous speakers. I think there's been some really interesting insight shared so far. The question that was posed to me, how can public and private sectors enable the conversions of smart, sustainable food systems in the bioeconomy? Clearly another big question, but something I thought I would use my experience in the AD industry to kind of talk through this as an example, really, and to show some examples of what's happening in public and private sector, trying to kind of converge these two systems. So as bioeconomy consultants, we are strategic business consultants covering the whole bioeconomy. So we're kind of well placed to cover this topic. It's really our bread and butter. So improving sustainability of businesses in both economic and environmental terms, kind of in its broadest sense, but kind of expanding reach into the bioeconomy, or kind of diversifying activities into the bioeconomy by kind of looking at biomass feedstocks, and looking at the energy and materials delivered by these new processes, products, or kind of methods. So AD, anaerobic digestion, is a means of improving food system sustainability through all parts of the supply chain, really, through production, so food production, through distribution and kind of process, and also through kind of use and disposal. So I'll talk about each of these individual components and then move on to some examples to try and show that. So just to kind of explain anaerobic digestion and the kind of context around I'm going to be talking today. So a number of different feedstocks can go into AD. So AD is an essential step of a sustainable waste management practice and an efficient recycling method, but it also contributes in numerous ways to other parts of the economy, as we'll see. So the idea with anaerobic digestion is it's a fairly versatile, flexible technology. It's a biological process that can process any organic material. So that can be products or co-products like crops and energy crops, or co-products. It could be agricultural residues, processing residues, or waste. And I think it's key, as you'll see kind of as we go through this presentation, I think it's really key that we kind of prioritise the wastes and residues as the feedstocks for AD, as opposed to the products and co-products. And it's really important that we get clear kind of direction from the public sector and engagement from the private sector, I think, in both of these areas, to really prioritise and focus where that feedstock's best used. So any number of these feedstocks can be fed into the AD process. It's a continuous process, so the system is fed regularly with a stable, secure kind of mix of feedstocks, fed into a sealed container, hence the anaerobic conditions, and out of that process you get a number of different outputs. So primarily you get biogas, which you can put through a CHP, combined heat and power engine, to get heat and power, which can be recycled back into the process, but also into the wider process. So you see this type of technology implemented in food systems, and where the energy is recirculated back into the food production system, either at kind of farm or producer level, or at processor manufacturer level. So kind of useful in that sense. Alternatively, and we're seeing kind of more policy push for this at the moment, is that biogas is upgraded into biomethane, and you get a natural gas type equivalent product, which can be distributed via the national gas grid, or it can be used for transport as a transport fuel in liquefied natural gas or compressed natural gas vehicles, or there are other ways that that gas can be distributed and used locally. So again, a real opportunity for that gas to be used back in the food production system to improve the sustainability there. And alongside the energy outputs, we're also getting a digestate, which is an organic fertilizer product, a biofertilizer, which can again be returned to the food production system. So generally the digestate is spread to land where the feedstocks that these kind of residues and wastes arise from are ultimately produced. Just in terms of the scale of the market in the UK at the moment, so we have 650 operational AD plants spread, as you can see from the map here, spread across the whole of the UK. AD is the kind of success of AD is so fundamental to the availability, security and stability of feedstock. So generally we see AD plants located where waste is generated or where population is based, and waste is therefore likely to result. So the kind of distribution generally follows the kind of population mapping. We see and we have seen and we continue to see fairly clear direction from the government in terms of how they want to see AD deployed and implemented in the UK, and how and where they want to kind of prioritise the outputs for the wider benefit. So the net zero strategy sets some clear priorities, and the industry, the AD industry, has been incentivised and encouraged by government for quite some time. But we see kind of the almost a realignment, restructuring of the policy landscape, which is favouring biomethane production rather than biogas combustion, because it's better aligned with the policy intent. So it's decarbonising faster, stronger and more efficiently. Greater efficiencies can be achieved through kind of this technology option, and markets can be much more kind of attractive and flexible. So really kind of giving a bit more optionality around where that supply is used, how it's used, and the benefits of that. In terms of feedstock use, so we're talking about bioeconomy, so biomass is really fundamental to that. UK operational AD capacity amounts to about 17 million tonnes of feedstock capacity at present. Significant volume there, and it very much follows the waste hierarchy. So waste will always be the priority feedstock for AD. Secondary to that are the residues, and then tertiary, you've got products that sometimes offer a bit of biological stability and help with the control of the system, but they're certainly not the reason why these projects are developed. So wastes, as we know, are favoured by the policymakers. The residues are generally accepted as sustainable, but that's got to be within extraction limits and on a value basis. So where's the best value? Where can the greatest value of that residue be achieved? If it can't be achieved elsewhere, then AD is the natural place for that. The graphic on the right here really just shows kind of what proportion of these currently available feedstocks is currently used in AD. So for processing residues, the kind of full length bar represents total availability of processing residues in the UK, and the shaded part of the bar is what's currently processed through AD. So currently about 70% of processing residues that are suitable for AD are processed through AD. Around 60% of food waste that's available and suitable is generated through AD, and about 50% of agricultural residues, with only about 3% of livestock waste generated in the UK being treated through AD at present, because it's a bit more challenging. It's lower yielding, it's not as attractive as some of the other feedstocks, or hasn't been so far. So that's really where we're at in terms of biomass and the prioritisation, which I think, again, it's really important that we get those messages from the government, from the kind of public sector. Where should these materials be prioritised, and kind of what technologies, what kind of hierarchy should be applied to that on a value basis. And I think we do have some really clear direction on that as an industry. I think it's really important that we look beyond the other energy benefit, look beyond energy to the other benefits. So in the AD sector, the incentivization, the regulation, the kind of main drivers have all been about the energy output, but to kind of benefit the public sector as well, the private sector as well as the public sector, we need to look beyond the energy benefits and look at the kind of wider potential of AD. So there's a long list of kind of other opportunities and other kind of benefits and impacts here. Looking more broadly at kind of energy security, the food security, the kind of sustainable food systems we've been talking about, looking at employment, the kind of social benefits, and also the government from a governance point of view. Lots of opportunities there. So AD can certainly tick a lot of boxes when delivered in the right place and in the right way, but we must think kind of beyond energy if we want it to kind of continue to be beneficial. There are a number of public sector initiatives already in place, ranging from kind of funding and support through kind of incentivization of the outputs, the use of the outputs, and compliance around making sure these things are done right. So EBNet, the Environmental Biotechnology Network, is one of the networks in industrial biotechnology, one of the NIB, and it's really enabling and supporting innovation in this area to improve overall sustainability, and I think to improve the interaction of this kind of sector with the broader sustainability agenda. And just, I said, I kind of use some examples or give some examples. So I think the pictures here kind of are examples of different types of AD units installed and operating in the UK. So these are really private sector initiatives where these facilities are deployed to improve the sustainability of food production in its broadest sense. So most of these systems are installed at farm scale, apart from the one on the bottom right of the screen, which is a food waste facility, but a relatively small scale food waste facility. These are all examples of how decarbonisation at farm scale and decarbonisation of that kind of biomass production, the food production, can happen. So as well as producing energy that can go back into the farm, into the kind of production elements, there is the opportunity, as I mentioned previously, for each of these units would generate digestate, which can go back into the food production system as fertilizer and kind of soil conditioner. Economies of scale very much apply to AD, and what we've seen in recent years is the whole industry has been driven to bigger is better, and that's not always the case. So my advice is always AD should be scale appropriate, and in a farm context, in terms of the food production systems, bigger isn't necessarily better. I think AD at this kind of scale, the top row of images here, at this scale, it really can have a big impact on individual farms, on the local area, the region, and the nation. But at this scale, it's really not going to take off without some form of support, encouragement, or incentivization. And sadly, the incentives have been driving the economies of scale and kind of pushing for the bigger scale. So we really need kind of more support, I'd say more support and encouragement from the public sector for this scale, the scale appropriate development that should be kind of focused on the wider benefits and not just the energy benefits. Some uses, so kind of just to kind of loop around to the circularity, the biogas, the biomethane that's generated in these on-farm sites, facilities, can be upgraded to biomethane and used in farm vehicles. So you are further decarbonising the kind of farming system, and the digestate there in the top right, top left-hand corner is an example of the material that can be returned to land. So AD is really circular, and I think there's a lot more that can be done from both private and public sector to kind of encourage wider deployments. Just a kind of penultimate slide. This is a larger scale facility, so looking really at where the kind of private sector can get involved and kind of encourage uptake. I think there's a real opportunity for these large scale developments to work better than they are currently, and for us to improve what we've already got on the ground. So we need what we need from both the kind of public and private sector, is market pull, actions that can strengthen that market pull to enable these facilities to operate better, giving kind of stable, secure and reliable offtake for the outputs, and also supplying a regular supply of the inputs. The market's clearly really well established, but there is a lot more that can be done to strengthen what we already have and improve that circularity. And it's important that all stakeholders get the recognition for the part they play and kind of the way they benefit in the supply chain. So we've seen real kind of rapid uptake in the use of biomethane in vehicles as a transport fuel in the last few years. We see kind of large cooperatives, private companies like Arla, the dairy cooperative, Waitrose, big corporates, Amazon, for example, kind of really strengthening the demand for biomethane and again improving the circularity from a distribution and a kind of collection perspective. And then we've seen public sector initiatives. We've got the poo bus, like the one on the top right. So this is a bus that's running in Bristol, fueled by biomethane from a sewage treatment facility. We've got buses in Nottingham and refuse collection vehicles also been deployed more widely. So yeah, there's a lot of activity and a lot of market pull coming through from both public and private sector, but I think there's a lot more that can be done there. And then just to finish off in terms of putting the final piece, that kind of opportunity jigsaw, community scale AD cannot be forgotten about. So there's a real interest from the community and kind of the public at present. And this is a very kind of active project that's happening now. So Circular Malton and Norton is a community interest company based in Yorkshire, in and around a kind of relatively small market town. And they have really pushed the consideration of AD as a solution for that town and for that kind of initiative. It really, Circular Malton has an ambition to make Malton and Norton adjoining market towns the first kind of truly circular market town in the UK, and they are making really good progress to do that. So they've done a lot of community engagement around having an AD plant within the town that treats waste generated within the town to return the benefits back to the local community, the local town, or facilities adjacent to the town, and really getting buy-in from a lot of key stakeholders within the community. So that includes the council, the local authority, so from a planning and kind of regulatory perspective, but also from kind of residents and businesses in the local area. And a lot of people imagine community scale will be something small like this, a containerized system where you are treating a small amount of waste, but actually this is the kind of initial outline concept design for the project that they're working on in Malton. So it's a medium, it's a kind of reasonable size facility that will get a lot of engagement. And I think this initiative is really keen to work with the local authority to align with an innovation hub. So the building that you see to the right hand side of this image is an innovation hub, and the idea there is that it provides a place for the local community, for public and private sector, to come and learn more about AD, develop innovation and improve the circularity of the town, as well as being a kind of visitor centre and education hub as well. So lots of initiatives going on in this sector. I think it's quite an exciting time, and I think there are still a lot of challenges along the way, but this industry is making really good progress in bringing together smart kind of sustainable food systems in the bioeconomy. So thank you.
Well, thank you, Lucy. Thank you for your insight on anaerobic digestion, and it shows how different stakeholders, public and private, can work together to promote and scale up the bioeconomy. But it doesn't go without controversy, though. I mean, you know that. So it's something probably that can be discussed at the Q&A. But we're going to move on to the Q&A now, because we've got 15 minutes left, and there are so many questions, and So I don't know if Steve wants to ask the questions specifically to the members of the panel, or if you want to take a general topic, without being too general.
I think we have several questions in the chat, so it probably would be better to go to those.
Yeah, I think there's a question around about the role of universities in this process of transformation and innovation. So that's more a question, I suppose, for Parag, I suppose, but for all our speakers. Have I lost Parag?
Yeah, hello.
No, yeah. Is there a question around universities? What's the role of universities in the process of transformation and innovation?
I think we lost him.
Yeah, we lost him. So
yeah, or he's frozen. Maybe. Oh, there you are, Parag. I think. Can you hear us?
Yes, there is.
Hello.
Hi, Parag. Yeah.
Can you hear me?
Yes. No, I think there might be a lag.
I think what would be interesting, so otherwise, is to talk about the UK strategy. I think Lucy has touched upon it, and it seems that it's interesting because it seems that there's a clear path for anaerobic digestion and support from the government. But from what we've looked at, it seems that in general for the bioeconomy, we are a bit in the dark. We don't really know where the country is going. Am I wrong, Steve, to think that? Is that something you would like to talk about?
I'm not really sure about, I'll be the best person to comment on where the country is going with that. I did have one thing I want to say about what Lucy was talking about. I mean, it was interesting to see that the initiative that Moulton is taking with anaerobic digestion. One of the questions that's always raised about valorization of waste and co-products is what scale it should be. What scale can we achieve it at? Whether it should be distributed processing or whether it should be sort of large sites where waste is brought in. Do you think that something like AD is far more suited to small scale processing than something like the biorefining processes that say Parag was talking about?
I think I come back to the point that I made, that I feel like development should be scale appropriate, and that's not just scale appropriate to its location, that's kind of scale appropriate to the feedstock it's using, kind of where that feedstock's coming from, how much is available, how secure that feedstock supply is, and what the alternative uses for that feedstock might be. It's also considering the outputs, so scale appropriate according to or the drivers. Why are you doing the AD project in the first place? Is it to generate energy, to kind of feed energy back into a process or a community? Is it as a waste treatment technology, and therefore you kind of peg it around, scale it around the availability of the waste that you're planning to treat, or is it around some of the other outputs like the digestate, for example, or something else? So I think, yeah, scale appropriate. Some of the projects that I showed you the images of are kind of where the industry is moving to be more scale appropriate, because the image that I showed of the large waste treatment facility is what the government has been incentivizing. So they've been incentivizing large centralized waste fed facilities, but we do have issues in the UK with feedstock. Often feedstock availability is the biggest constraint for these operational sites. So many of them operate at kind of 60–70% capacity. Whereas if you're developing smaller, more scale appropriate projects that are not necessarily hitting the sweet spot with the incentives, then you don't have those issues with feedstock. So I think, yeah, there isn't a simple answer, but hopefully that gives you an indication.
I suppose feedstock stability is an issue in some cases, as there are some that you just cannot transport without cooling them, which is energy intensive itself.
Yeah, I mean, feedstock's the most important part of an AD project. So you need to really have a firm feedstock strategy and some firm direction on feedstock before you go ahead and develop a project.
You're muted,
Yeah,
Sarah.
that's it. There was a question for Duncan first about certification. What's the role, do you think, in the terms of, with the development of the bioeconomy, the role of certification of sustainability standards? Do you think it will be still necessary, or are we going towards something a bit more, outcome oriented rather than certification oriented?
Yeah, I mean, I'd like to see us moving towards more outcome orientated. I think certification has a role, but it has massive issues, because a lot of, normally for any product, there's more than one certification system. So say if you're looking at palm oil or soy, you might have the responsible RSPO standard, but there's many industry-led standards as well. And the problem is, it's very hard for citizens and for people in business to identify which certifications are valid and truly sustainable, and which ones are just greenwash or have very, very weak standards. And you see that particularly across the seafood industry. There are so many, it's about 60 different certification standards. So the problem is there's too many. They're often, the weaker ones are often introduced to confuse, and they often don't need much more than doing the legal minimum. So example of the certification standard in the UK that's very well known is Red Tractor. Red Tractor is basically the legal minimum for farm food on the UK production. And this basically means it's British produced. But the assumption amongst citizens is that Red Tractor means high environmental standards and high animal welfare standards, which it doesn't. So certification is tricky. It's really important, though, to have good quality, valid certification systems for food businesses and citizens to identify what is good as opposed to what is bad. But I think we should always be moving towards an outcome-based system where the default setting for the food in the businesses on your plate is sustainable from the sustainable system.
So we're gonna take a question from a member of the audience who wants to answer your question directly. It's Isaias. Am I pronouncing correctly your name, Isaias?
Yes, thank you, Cyril. I would like to thank all of you for a very thoughtful talks that you gave, and and a lot of food for thought, actually. So my background is in architecture, so I am not an expert in bioeconomy but I because of my interest in ecology, I have read a little bit about it. So the definition is really important, I think, because like life-based economy, which promotes, and we can learn a lot from life, and how can we use that to exchange and make our lives much better for all of us, which I agree with a lot of points that Duncan Williamson made. So thank you for that. I think one thing which I've from what I heard is like a lot of focus in the definition towards technology and science, which I think that is already, if we see in the health of the world population, is like with the development and intervention, technological intervention in food systems, there has been a lot of decline in health. Like there are obesities, as Steve said earlier. There is diabetes. Like in America, it's like people with diabetes are more than 40%, and people who are pre-diabetic is about like 84 or 80 something percent, like huge numbers. And in UK, like I think 3 out of 5 will be susceptible for cancer. Like there's so many things that are going on, and that from what I've read is like
Sorry,
pollution.
Sayas. Sorry,
Yeah.
Sayas, to
Yeah.
rush you because we are running short of time. So, what's your question exactly? I mean, it's really good
So
comments.
I mean, like it is life-based, but it is very technological. It goes towards technology. So I think we should be aware, like natural and we should go into the food that we evolved with. I think like that's my point basically. So and not into very synthetic and technological kind of processed kind of foods. That's basically what I wanted to share.
Yeah, no, it's
So-
very interesting. Yeah, obviously, yeah, we're talking about moving away from agriculture basically to feed. So that's something to look at. But as I always say, we look at agriculture from a very idyllic point of view. But the reality is that so far the agriculture has been pretty harmful to the environment, and
Yeah,
so
exactly.
yeah. So no, it's a complicated topic. Does anyone want to, because we are about to conclude, I suppose I'm going to wrap up soon, but thank you, Isaias, for your very valuable comments. Does anyone want to say something, make a point? Do you want to, is there something that you think that the audience should know about, or what would be the next step?
Cyril, just one thing about.
Sorry, the question for you. Sorry.
Yeah, just is it possible? Like, I mean, if I can
Yes.
quickly come back. No, I think it's a very good question on that aspects of how a university or knowledge institutes can actually contribute. I think one part we need to be very clear about that how to create a win-win. Yeah, so win for university and win for basically the companies or the consumers. So in that aspects, I would say one part is that what university can do is basically de-risk the technology or innovation, the concepts, by actually doing a lot of feasibility work, where also develop the fundamental sciences. And I think that's one way to look at that, the participation in university. And the second way, I would say that also there are a lot of lack of knowledge in terms of the consumer behaviors and others, yeah, where basically universities and the knowledge institute can really comes into the play, because as Duncan and many others have also pointed out, that most probably the manufacturers and the food companies are a bit biased. So basically developing a non-biased knowledge among the consumers, among the people, that's where the university could play a role, which actually help for the feasibility of the technology or innovation or research, in the bioeconomy. And this is an evolving subject. So I think better and earlier you can engage, you can leverage that the whole knowledge remit more.
Thank you, Parag. Does anyone want to say anything before we wrap up? Thank you very much. It was a very broad topic, and we hope that this might lead to a participatory workshop further down the line. We knew it was a very broad topic and it would be difficult to keep everything within 2 hours, because we've got a range of speakers who are experts in their question and very passionate about what they do. So it was a tough challenge. So thank you very much to everyone. Has anyone got to say anything? You want to say something?
Just final comment, if I may, Cyril.
Yes, you may.
So I heard all the panel members, and thank you so much for your insightful thoughts and experiences, sharing your experiences and your research. So it was really helpful for me, and I'm sure it would be helpful for others. What we would want to do from here on is, like, at least have some sort of report made for the key findings and the key discussion points that has arisen from this panel discussion. We would be in touch with all of you who have provided your details in the chat and who are wanting to continue this conversation. And once we have another opportunity to run a participatory workshop, we would invite you to see if we are able to co-design some of the proposals together and move this forward. Yeah. So thank you.
Thank you, Sonal. So I'm going to thank you, our speakers. Lucy, Parag, Duncan, and Dele. Thank you very much for your participation. It was really, as you said, Sonal, insightful. Thank you to Steve as well for being the brains behind all that.
Thanks, Steve.
And yeah, hope to see you soon. And just on a personal level, really thank you very much, because I'm much smarter now, 2 hours after. So that's good. That's good.
Thanks a lot, Cyril and Paulina, for organizing this. Well done.
Thank you so much. Thank you.
Thank you.
Have a good day,
Thank you for
everyone.
having
Thank you
me.
so much.
Thank
Have
you
a
so
good day.
much.
Cheers.
Bye.
Thank you.
Bye.
Bye bye.